Hello students, so now let's start with our next chapter, that is thermal properties of matter. Chapter wise discussion, JEE in 2025 January attempt. Let's start with our first question, that is, see here. Okay, so some mass is given and some minus 10 degrees centigrade to 110 degrees centigrade. You have to take it this 10 to the power minus 3 kg. Okay, so specific heats are given, latent heats are given. Okay, so take this as, so let's write down. What he's saying is basically calculate the work done or basically the heat given. Okay, that is nothing else. So what he's saying is, so first you have minus 10, right? So from minus 10 you will take it to 0, right? So from minus 10 to 0 means ms delta T. So m specific heat of ice into delta T. Delta T is how much? 0 minus 10. 0 minus minus 10 means how much delta T? 10. That's it, 10 plus m into L. At 0 degree centigrade you are changing the state, so m into latent heat of ice plus then m mass is going from 0 degree centigrade in liquid form to 100 degree centigrade liquid, right? So there ms delta T, m specific heat of water into delta T. Delta T is how much? 100, right? Plus m into L. Now from water you are going to vapor, right? So mass into latent heat of vaporization, right? Plus what? Mass into from 100 degree centigrade vapor to 110 degree centigrade vapor, right? So m specific heat of vapor into delta T. Delta T is how much? 10. Okay. These all values are given to you in the answer. Just put the value, get the answer. Let's see. Solve it. Mass m. So take m common here. Okay. Specific heat of ice into 10. So specific heat of ice is given to you here. 2100, right? So 2100 means 21 into 10 is to power 3. Okay. And this is m is there given to you 10 is to power minus 3. Okay. Plus latent heat of ice. Latent heat of ice is how much? Latent heat of ice is 3.35 into 10 is to power 5. 3.35 means 335 into 10 is to power 3. Okay. Plus mass already out. Specific heat of water. Specific heat of water is given to you 4180. 4180. 80 and 100 is there, so 10 is to power 3. Plus latent heat of vaporization. Latent heat of vaporization is given to you steam. Latent heat of steam, latent heat of vaporization, same thing. 2.25 into 10 is to power 6. So 2.25. So 2250 into 10 is to power 3 plus specific heat of vapor that is given to you, specific heat of steam 1920. 1920. Okay. So 1920 means 192 into 10 is to power 3. This. Okay. 10 is to power minus 3 will go inside, 10 is to power 3 got cancelled out, right? So you will have how much? You will have 21 plus 335 plus 418 plus 2250 plus 192. Okay, this will give you the answer, exact answer. Okay, so if you solve this, okay, then you will get, okay, then you will get your answer. First option 3043, exact answer comes. Okay, nothing approximation, just directly this answer will come 3043. Okay, this is how I made my calculation easy. Okay, otherwise 10 is to power 3 will run everywhere. You don't have to take this easier calculation. This will come in joule only. Okay, this you have to check. One thing you have to check here, everything is in joule per kg, nothing is in kilojoule, otherwise I have to change it. Okay, and nothing is there is in gram, everything is okay. Mass is in kg, that's also okay, right? So every specific heat and every latent heat you have to check, joule and kg is only there. Okay, then only you will able. Okay, so that's how, that's your first question. Let's go for the second question. So for here, two spherical bodies of same materials having radii 0.2 and 0.8 meter are placed in same atmosphere. Okay, means at outside temperature is same. The temperature of the smaller body is 800 Kelvin and temperature of the bigger body is 400 Kelvin. Okay, if the energy radiated from the smaller body is E, then the energy radiated from the bigger body is, okay. So understand it like this: dq by dt radiated will be E sigma A T raised to power 4, right? It depends upon the body's temperature, right? So for the bigger body, if you write down, right? For the bigger body, let's assume this is E dash, okay? So that he is saying E sigma same, okay? And area wise, what we can say, bigger body is 0.8, right? So we can say pi 0.8 square, okay, into temperature. For the bigger body, what is the temperature? For the bigger body, temperature is 400 Kelvin. So 400 raised to power 4, okay. And for E which is for smaller body, E is saying same E sigma into pi. This will be how much? 0.2 whole square into this is 800 raised to power 4, okay. So if you divide, if you see here, there is a 4 factor, so 4 square 16 here is extra factor, okay. And here also if you see, there is 2 raised to power 4 16. If you divide both of them, you will get E dash is equals to E only, okay. This you get, understood? So radiated, the energy will be same, because here this temperature factor and this factor is getting cancelled out with each other, okay. This is making it same. So your answer is second option, okay, directly. Now let's see the same, the formula is there, okay, this formula if you remember. Now let's see next question number 3. 3 is given this question, okay. This question is also like notes question only, just values are changed, okay. K1, K2, K3 are conductivities are given, and 3 conductors of same length. So this is also L, this is L, and this is L, okay. K1, K2, K3. Area of cross section of first and second conductors are same. So this is A, this is A, this is 2A, okay, like this, okay. Is double first conductor, okay. The temperature are given in the figure. So 100 is this side is 0, and this side is theta, okay. In a steady state condition, the value of theta is, okay, see here, like this it is. You assume like this, there is a rod, okay, then there is a rod, and then there is a rod, okay. So this area of cross section A and 2A, right? Here you assume theta is there, here 100 and here 0, okay. So first of all, if I combine both of them, okay, so here resistance will get added directly. Sorry, R equivalent, what will come for these two? So change the pen. For these two, R equivalent will come what? R equivalent is what? R1 R2 divided by R1 plus R2. What is R? R is basically for any rod, L by KE is my R, right? Put the value. So length is same for here also L and for here also L only, right? So what can I say? L by K, R1 R2. So this is basically L by KE. So K is K1 K2 is given, right? K1 and K2. K1 K2 values we will put later on, okay, not now. So basically K1 into area A plus, sorry, multiply L by K2 into A divided by, this will L by L and A will come common, and you will have 1 by K1 plus 1 by K2, okay. This will come. So if you solve from here, what you will get? You will get L by 1 will cancel out, that's L by A will be only remaining, and then you will have in multiplication, this will be K1 K2 and K1 plus K2, right? So denominator K1 plus K2, that's it, okay. This will be your remaining things, okay. Now this came for this, so now we have new system. So just see like this, we have one whose area of cross section is A, leave it, now we don't need it, okay. Just see here, we have R equivalent here, okay, and we have one R here. What is this value of this R? This value, R value, I can say L by K. So L is L only and K is K3 and area is 2A. This you have to see here, 2A, okay. This is R equivalent, this is R. Now just see here theta, here is 100, here 0, okay. Degree centigrade, obviously, okay. Then what you do is, from here heat going this side, okay, heat current going, sum is 0, that's it. So making this temperature higher, or you can understand second way also, but as I said that maybe this point is 3-point junction or 4-point junction, right? 4 rods are coming here on this point, right? That's why I always told that from here you assume heat is going outside, right? And sum of the heat is 0. So this temperature is assumed, this temperature is higher from this and higher from this. And what you will write down? You will write down theta minus 100 by R. So this is R equivalent plus theta minus 0 divided by R is equals to 0. Okay, I already know this is gonna come negative, this is positive, but total will be 0 because heat radiating from this side, total is 0. Okay, so from here if I see, what can I say? 100 minus theta divided by R equivalent. R equivalent we calculated just on the previous page. What is that? L by A into K1 plus K2. Okay, so put that value L and multiply by A into K1 plus K2 is equals to, because I took this quantity that side, okay, to make positive, theta divided by R. R value is what? L into 2A into K3. Okay, I am going slow because you have to understand the calculation and everything. So L A got cancelled out. Okay, now put the value of K1, K2, K3. So you have 100 minus theta into K1 plus K2. So K1 plus K2, if I do K1 plus K2, this will be 180, right? 180. 180 is equals to theta into 2 times of K3. K3 is how much? 135. 135 into 2. So 2 into 135, how much? 270. Right? 270. Okay. So that's it. Now get the answer. So what we can say here, 0 got cancelled out. 9 by 9 table, you have 2. Here this is 3. Right? So you have 200 minus 2 theta is equals to 3 theta. And so theta is equals to 200 by 5, that is theta equals to 40 degrees centigrade. So 40 is your answer. So your answer is 40. Okay, so 40 degrees centigrade is your answer. Now let's go for the next question. Okay, next, a gun fires a lead bullet of temperature 300 Kelvin into a wooden block. The bullet, having melting temperature 600 Kelvin, penetrates into the block and melts down. If the total heat required for the process is 625 joule, then the mass of the bullet is. Okay, basically understand, the bullet was at 300 Kelvin, okay, and then it melted, and you know it will melt, melting temperature here 600 Kelvin, okay, and to do this whole process, it's 625 joule energy is required. So basically saying it like this, 625 joule is equals to, from 300 to 600 you have to go, so delta T is how much? 300. So M, specific heat of that particular metal, into delta T, that is 300. Okay, basically 600 minus 300. Okay, then you reach the 600. Now from 600 you have to melt also, so plus M into L. Okay, that's it. So from here you have to get the M. Now let's put the value. So if we put the value, everything okay, unit is okay, but he is asking in the gram. Let's calculate in the kg, then we will convert into gram. Okay, so M will be how much? 625 divided by specific heat of metal is given 125. 125 into 300 plus latent heat is given how much? 2.5 into 10 to the power 4. 2.5 into 10 to the power 4. Okay, and if you want to convert into gram, then the power 3 is there. Okay, so M 625, okay, divided by, this is how much? 3. If you multiply, this is 375, right? 375 into 2 power you can cancel. 2 power, if you cancel out 2, this is 110 is remaining, right? So just 110. Okay, so 375 plus this will be 250. Okay, That's it. And here multiply by 10 is out. Okay, calculation mistake you should not happen. That's the most important thing. So 625 0 and this is 375 to 500 and 600, right? 625, right? This will come 10. Okay, the answer is 10 gram. Okay, the answer is 10 gram. That's it. So answer is 10 gram, first option. Okay, fourth, first option. Now let's see next question. Fifth, which of the following represent the relation between Celsius and Fahrenheit temperature? And 9th class student can answer this question. Okay, Celsius and Fahrenheit relation. We have derivation also, how this Fahrenheit scale came. Those all things also I told you. C minus 0 divided by 100 is equals to F minus 32 by 180. From here C is equals to what? Because C is on the y-axis, right? So I will take C this side. So how much is this? This is 9 by 5, right? 5 by 9. F minus 32. Okay. So this is positive slope with a negative intercept. Positive slope and negative intercept, fourth option. Okay. So fifth question, fourth option. Okay. Understood? Now let's go for the next question. Sixth, the temperature of the body in air falls from 40 degrees centigrade to 24 degrees centigrade in 4 minutes. Okay. The temperature of the air is 16 degrees centigrade. Okay. So outside atmospheric temperature is given 16 degrees centigrade. The temperature of the body in the next 4 minutes will be. Okay. So basically he is saying like this, that initially body temperature is 40 to 24 is going. So from 40 degrees centigrade to 24 degrees centigrade is going in 4 minutes. Fine. And then next 4 minutes where it will be. So from next 4 minutes, what is the temperature? T. Okay. And atmospheric temperature is given. Outside temperature is 16 degrees centigrade. Okay. So here you apply Newton's law of cooling. Approximated version. The last approximated version we have studied, that I said that when you write down dt by dt is equals to, if you remember, minus C2 into T minus Ts, right? That you write down. But we have approximated this also, if you remember. How we approximated? We said T final minus T initial divided by time, basically delta T. Okay, temperature. This is time. Okay, delta T. Or you write down just a small t only. Small t. This is T final minus T initial is equals to minus C2. Minus is basically denoting that as temperature is high, so this will be negative. Okay, automatically here negative will get cancelled out. I will show you how. So minus C2 into this T, you take average of initial and final. So what you say, T initial plus T final divided by 2 minus Ts. Okay, that's your equation. Okay, so now just apply on this 2. Here you apply once and here you apply once, then divide, C2 will get cancelled. Okay, now let's see how we are saying. So apply this equation, T final minus T initial. So if you say here, so here what can I say? T final is what? 24. So 24 minus 40, negative number. That negative will get cancelled out with this negative. That's what I am saying. Okay. So here 24 minus 40, how much? 16, right? So minus 16 will come, that will get cancelled out. So 16 by 4, okay, is equals to C2 into T initial plus T final by 2. 40 plus 24 by 2. So this is 64, 64 by 2, 32. 32 minus 16, right? Okay. So here this is 4. Don't cancel out it. Just leave it like this. So 32 minus 16, 16 only. Right? And this is first equation. Second equation, what can I say? T final we don't know. This is T, right? From this point I am applying. Understood? This will be more difference. This temperature I will apply. So T minus 24 divided by 4 minutes only is equals to minus C2. So this will be less, right? This T will be less. So let's take this as 24 minus T. I am adjusting the negative sign here. So this will, I take it C2 only. Okay. And then I am saying T average. Average, what do you say? T plus 24 divided by 2 minus 16 here outside. Okay. That's how. So now what you do? Simplify a little bit, but take 4. Okay. Okay, we can take the 4 that side. So this will be 4. Okay. This will be 4 here. C2 will be 1 by 4. So take the 1 by 4. C2 value if you put here, what you will get? Okay, 1 by 4 if you put, this 4 will get cancelled out, so C2 will get cancelled out with this. Then you will have 24 minus T is equals to, if you say here T by 2, and this is 12, 12 minus 16 minus 4. Okay, so take T that side, this will be T 2 by 3 multiply by 24 plus 4, 28, right? 28. So T is how much? This is 40, 56, 56 by 3 degree centigrade. 56 by 3, 56 by 3, 56 by 3 we have fourth option. Okay, so sixth question, fourth option. How we did? If you see once. So basically you applied this form. This you remember, okay? Okay, this I told. Okay, if you see on the YouTube also, we have lecture about the radiation. There I explain this, how the derivation came, how approximated, more approximated. Every definition is given there. Okay, from this equation comes, taking T as the average and this T as the change in the temperature. That's all. Okay, for a very less change in the temperature, we can apply this equation. Okay, so comparison to 16 degree, 16 is the only change, and the temperature is 40 plus 273, right? So comparison to that, this is very low, change is very low. So that's how we can apply this equation. Okay, so 56 by 3 is your answer. Next question, seventh question. A cup of coffee cools from 90 degrees centigrade to 80 in T minutes when the room temperature is 20. The time taken by the similar cup of coffee to cool from 80 to 60 at the same room temperature is, if you see, there is no difference between sixth question and seventh question. Okay, between sixth and seventh there is no difference. Okay, 90 to 80 there is T minutes. Okay, apply the same what you are seeing, 90 to 80. So 90 to 80 T minutes. If you write down like this, then it will be very easier. Otherwise, for every information you have to go into the question again, right? That will be more problematic. And the room temperature is 20 degrees centigrade. So room temperature is given 20 degrees centigrade. Okay. Time taken by the similar cup of coffee to cool from 80 degrees centigrade to 60 degrees centigrade. Now from 80 to 60 if you go, then how much T dash time it will take, that he is asking in terms of T. Okay, at the same room temperature, everything is same, means C2 is same. Okay, so again we will apply the same formula. So what we said about that formula, T final minus T initial divided by time is equals to minus C2 into T initial plus T final by 2 minus T surrounding. Okay, that's what we said. Now apply this formula here. What we can say, T final is what? 80 minus 90 minus 10, minus will get cancelled out. This T 10 by T is equals to C2 into T initial plus T final by 2. So 80 plus 90, 170, 170 by 2. 170 by 2 is how much? 85. 85 minus outside temperature 20. Okay, so that's what it came. Let's keep it 85 minus 20, 65. Okay, so write down it 65. Let's keep it this way only, and then write down second equation here only. So second we are saying 80 to 60, right? So minus 20, minus will get cancelled out. This will be 20 by T dash is equals to C2 into, now T initial plus T final between these two temperatures. 60 plus 80, how much? 140, 140 by 2, 70, 70 minus 20, 50. Okay, that's how, right? 140, 70, 70 minus 20, 50. Okay, that's what we got. So from here, if you divide both of them, what you get? T dash, so 10 by T multiply by 20 into T dash is equals to, this side you will get 65 by 50. Okay, this is what you get. So T dash is equals to basically 2 into 65 by 50. Okay, so here 5, this is 13, and this is 5 into T. T dash is basically 13 T by 5. 13 T by 5. 13 T by 5. This is fourth option. Okay, so your seventh question answer is fourth option, 13 T by 5. So there are two questions which are similar, 29 Jan shift 2 and your 24 Jan shift 2. Okay, these questions exactly came in the basis on the same formula, right? Because JEE doesn't change the level of question too much. Okay, that's why they keep from the same concept, changing the value or changing the terminology of the question. They give that kind of question only. But still, the questions are from the notes. So even you don't know this 24 gen shift to this question came, still you know, right? Because many questions you have practiced in the module, right? Thank you for this lecture.